to kick in.
Oh, okay. Hello, everybody. I can't really see too many people, but I'm glad you're out there. And my name's Eileen. Oh, hi. And I work for the National Center for Atmospheric Research in Boulder, Colorado. And I am a science educator. We're going to do a cool activity today. Maybe you have some of the supplies you need. Maybe not, but either way, it's okay. This is my colleague, Tim, that you can see, and you
Hi,
can see
everybody.
supplies in front of him. And he's gonna, even if you don't have the supplies, it'll be fine because you'll be able to see what he does. So what we're gonna do is if you wanna say anything in the chat, make sure you can. And also, let's see. Yeah, we're going to be kind of working this activity into having to do with weather and clouds. So you'll see how that progresses over time. So go ahead, Tim. I think you can start away.
Okay, thank you, Eileen. And hello, everyone. We're excited to have you here. And we'll just get started with our activity. We'll be exploring, as Eileen said, we'll be exploring, and just to make sure you can hear me, can everybody hear me? Thumbs up. Okay. Yeah, I'm looking over there just because that's where your monitor is. And every once in a while, I'll glance over there. But yeah, we're going to explore how air behaves when it changes temperature. And then we'll figure out how that connects to the way some clouds form, like a cumulus cloud. And maybe you've seen clouds that look sort of like this before. Yep. Okay. So we're going to figure out how that connects to where the clouds change. And if you have a bottle, and I have a bottle here, maybe you don't have a bottle with you, but if I look at this bottle, do you think it's empty? Yeah, it's a little hard to tell. It does look empty, but it's actually full of air. Just like everything else, air is made up of tiny molecules, and they're so small that we can't see them. But molecules take up space. So the air molecules inside this bottle are invisible, but they're also taking up space inside the bottle. And we're going to find out what those molecules in this bottle do when they get warm. And if you have these with you, and I'm looking over, it doesn't look like everybody has the materials with you. So I'll just do this here. And the first thing I'm going to do is I'm going to dip the bottle into this little tiny tub. And this inside this tub is dish soap and water. And I'll dip it in there until I get a bubble on the top. And there's a little tiny bubble on there. And then I'm going to take the bottle and I'm going to dip it into the hot water and into the cold water. But before I do that, I'm going to ask, what do you think? Think in your head, what do you think will happen to that bubble when I put it into the hot water and the cold water? I'll give you a couple of minutes to think about what that bubble might do. And let's see. I'll hold that. Can you see anything on the end of my bottle there? Eileen, can you see anything on there?
I can see a little shiny thing. Oh, yeah, it looks like a bubble.
Okay, so there's a bubble on top.
It looks to me like this is something kids could do at home and show other people because they have all of these supplies.
Yeah. Okay, so we're going to go ahead and start. And the first thing I'm going to do is, I think my bubble might have popped. So if it does, I'll just get another bubble. And I'm going to go ahead and set it into the hot water. And can anyone see something happening there?
I think I see something. Oh, the bubble.
It's growing.
Growing, yes, it is growing.
It is getting big.
And was that what you thought would happen? Did you think it was going to grow? Yeah, maybe.
Maybe.
Oh, and it popped. So I'll get another one and see if it happens again. Okay, I put it into the hot water. Oops, it popped already. All right, it's in the hot water. It's growing. Now I'm going to take it and put it into the.
What,
Let's wait. Maybe we should get a bigger bottle. What do you think?
and what I wonder what's going to happen when you put that bottle into the cold. It looks pretty icy, that water.
It's gonna shrink.
It's going to shrink.
Somebody says it's going to shrink. Oh my gosh. All right.
Okay, well, let's see if we can.
It's not going to get bigger. It's not going to pop. You think it'll shrink. Okay.
Okay, we got a little tiny one. Oh, we got lots of them. Let's see. All right, now I'm going to dip it into the cold water.
Whoa.
Oh my goodness. Did you see that?
It shrunk. I knew it.
You knew it.
They're
You knew it.
opposites.
Okay. Should I do it again?
Yeah, let's do it again.
I'm going to heat it up just a little bit. Oh, there it goes. That didn't take long. And then we'll go into the cold water and.
There it goes.
There it goes.
If they're opposites, they probably do opposite things.
Yeah.
They are definitely hot and cold are definitely opposites. And is up and down opposite too?
Yeah.
And there it goes. Oh, it popped. Let's see if I
Ooh,
can get.
what if? I think you should try putting the bottle with the bubble in, mixing cold and hot water.
Oh, cold and hot. Okay, we could do that, but what? There's something I wanted to show you. After it gets big, like that, and I don't know if you could tell, but it's going down, and it's a little hard to tell, but that bubble is all the way down here now. I don't know, maybe you could see that a little bit. So it's all the way down at the bottom. If I go back to the hot water, going up and up and up and up and up and up and up, and if it stays together, it might even come out of the top.
It went down all the way.
Hey, Tim, I have a question.
You have a question? Go ahead.
I have a question. Why doesn't the bubble go all the way down to the bottom of the bottle when you put it in cold?
Let's see. I'm just gonna get one bubble in there, and we'll watch it in the cold, and we'll leave it in the cold and see if it goes. It's right there, and it looks like it's stopping.
Why isn't it going all the way down?
Well, there's actually air down below it, and that's what I wanted everybody to find out, is that if you're wondering what's happening inside, as the hot water heats up the air in the bottles, the air gets warmer and the molecules spread out and expand. And when those molecules expand, they inside the bottle, they take up more and more space and make the bubble grow bigger on the top. But when you move the bottle into the cold water, the bubble goes down into the neck of the bottle. And this is because the cold water cools the air in the bottle, and the air gets cooler. Those air molecules huddle close together, which is called contraction. And those cold air molecules need less space, so they sink down into the bottle, and that's why the bubble behaves that way. And I was wondering if you could do like I do and show me with your arms when the air expands. Can you do expand with your arms? You can stand up and stretch your arms out high above your head. This is what the air is doing when it's hot. Is anybody able to do that? Eileen, can you see?
I can't. No, I can see myself.
Okay.
I can see myself doing it. I see. Yes. Ellen,
Okay.
Ella and Garrett are doing it. Yeah.
Okay, and then next, when the air gets colder, so imagine that you're like step into the cold water, and it contracts, and all the molecules huddle together. Squat down and bring your arms close into your body.
Well, yeah.
Just like that.
Yeah, they look like bottles.
Not one.
You're not a bottle. That's right. You're not a bottle.
Not bottles.
Not a
Well,
Human.
that's great. That's awesome, everybody. And I wanted to connect this to the weather now, just like I showed you the cloud. We're going to show you some cartoons or like drawings. And I think Eileen's going to share that. I'm looking over to see if Eileen's going to share that for you.
Yeah.
Almost there.
Yeah.
So there's going to be a picture. It's not really a picture. It's an illustration. And it's like a diagram of what happens outside. And what you'll see is a picture of the ground and the sky. And if you can imagine,
say yes.
when the sun comes up in the morning,
We're having cheese and
Yeah. No.
so that
to watch
the sun rises and gets higher in the sky, and it begins to warm the Earth's surface. And as the Earth's surface warms up from the sun's heat, the air above the ground also warms, just like the air did in our bottle. And that warm air expands, it begins to rise into the atmosphere. And if we could see it, there might be like little squiggly lines. Maybe sometimes you've seen that happen before. A little, it kind of looks like the ground is kind of, or the air is kind of wet. So as that air rises into the sky, it cools, and the air, so if there's any water in that air, it condenses into little cloud droplets, and they form to make a cloud. You might be able to see in this picture, there's blue sky under it. Up above is where the water that's in the air has risen to form a cloud. And I'm going to switch pictures now. Are you ready? Have you ever noticed a cloud that looks more like this, where it's very puffy? I'm looking over to see if y'all, yeah, have you seen this before? Okay, so in this case, the air is still going up, even though a lot of the water is condensing out of it. It's blue sky up here. As a matter of fact, if you ever see a cloud like this, that cloud is made out of water. And if you see clouds that are kind of fuzzy, those clouds are made out of ice. And if this keeps going on all day long, what can happen is a thunderstorm can form. And give me a thumbs up if you've heard of a thunderstorm. Yeah, you definitely know about. Okay, maybe thunder. What comes out of a thunderstorm, everybody?
Lightning and rain and thunder.
Lightning and thunder, yes. And I had a thunder tube here so I could make some thunder for you, but I lost it. But that sound like thunder?
Lightning.
Yeah, yeah. So everybody, that's what drives those clouds to form, is the air expanding, going up into the atmosphere and the water condensing, and those clouds forming. If that happens really fast, it can create a thunderstorm. And we know that lightning comes out of there. Can anyone think of another kind of weather that comes out of a thunderstorm?
Rain?
Rain? Yes, definitely rain.
Can you
There
make
were
rain?
clouds.
You want it rain? Rain? You can make rain like this. This sounds like rain, doesn't it? Oh, does that sound like rain?
You know, I just happen to have something sitting on my table. I'm going to move this in front of the camera. It's kind of bright. Let's see if I hold it back here. It looks like a cloud, doesn't it? This is actually a copy of a hailstone. The real one melted because it was made out of ice, so it melted. But this was the world's record hailstone back in the year 1970. It fell in Kansas in a city called Coffeyville. And you can kind of see how big it is when I hold it next to my head.
It might be as big as my brother's head.
As big as your brother's head? Yeah, that does look like, well, I've never met your brother, but I can imagine it probably as big as his head. And I'm going to hold it closer to the camera. And I don't know if you can see this because my lights are kind of weird. Do you see all those bumps on there?
Yeah. Yeah.
Yeah, those are the places where as the hailstone fell, and Charlie, the scientist at UCAR who actually had this sent to him from Kansas, said there was grass on the bottom of it. And at the very top, that's where any of the water that was still not frozen spikes as the hailstone fell. And if hail is this size, meteorologists will call this severe weather. Do you think this would cause damage if it landed on a person or a property?
Yes.
Yeah. And this hailstone is no longer the world's record hailstone. There was a bigger one that fell in a place called Vivian, South Dakota. And it was about this size. And then just 2 summers ago, one in Argentina fell, and it was slightly bigger. It weighed over 2 pounds. And I don't have a picture of it yet. They still are, the scientists are still, they have it in their lab, so we haven't seen an official picture of it yet. And I think we might have do we have enough time to have them answer?
I was going to try and share my screen again, which didn't work
Okay,
before.
great.
So I'm going to see if I can do that.
All right. Ooh, there we go. Ah, yeah, so this is the part where during the day, as the sun rises, it gets higher and higher in the sky and it warms the Earth's surface. And then as the Earth's surface warms up and it gets higher in the sky, the air expands, or the air surface expands, begins to rise higher into the atmosphere. Can you see the squiggly lines on the bottom?
Yeah.
Yeah, those are not really, they don't really happen. That's just to show you can't
Heat
see
rising?
it, but sometimes the air looks kind of wavy, so that's what the squiggly lines are. And then in the next slide, as the air rises higher and the water in the air condenses to form clouds, and again, those clouds are made up of little tiny drops of water. But as the clouds continue to grow and more warm air rises into the atmosphere and cools and condenses, those clouds get bigger and bigger. And if the water droplets and ice crystals in the cloud become too heavy or heavy enough, they eventually start to fall to the earth as precipitation. And then we have another picture of a thunderstorm that looks just like this. And what's that white thing coming out of it?
Lightning.
Lightning, yes. And I think that's actually, that looks very similar to my thunderstorm picture that I had here, but I don't know, maybe not. Maybe they're two different ones. And we know that we can get hail. What else can come out of a thunderstorm like that?
Hail.
Hail, and I'll give you a hint. Hang on, I have it right over here.
A hurricane.
Yes, a hurricane or a tornado. Let's see if I can make a tornado in a bottle. Can you see that?
Yeah, I just thought of it. I made a hurricane in a bottle on Friday. It didn't work.
Oh, it didn't? Mine's not working that too well either. Let's see if I can get it going.
I can see it. I can make
You
a
can see it?
tornado in a bottle with only one bottle.
Really? Whoa. There we
Yeah.
go. There's a little bit more of a tornado. And funny enough, the scientists who study tornadoes have found out everything that's a fluid, even air is a fluid, the way it moves faster from one place to the other if it's going around in a spiral like this as a tornado. Should we see if there's any more questions, Eileen?
Yeah. Does anybody else have any other questions before we finish up? I don't think so. I don't see any in the chat. But if you're interested in weather, which I think a lot of people are, I put
What's your question?
I put something in the chat that shows the links.
Cold and warm water mix.
Oh, the warm and the hot water mix.
Oh, you want to do that?
Garrett wanted to try that.
Yeah.
Okay.
Okay.
Should I put pour the cold water into the warm or the warm water into the cold?
The cold into the warm, but don't make the ice go in the warm because then the warm will turn to cold.
Okay.
Because it's ice.
Right. Okay, here we go. Tell me when to stop.
Stop. That's probably good.
Okay.
I've tried the bottle. It's gonna be. I wonder what's gonna happen. Maybe it's gonna stay in the middle.
Ah, that is a good idea. Oh.
Ooh, is it? Can you see it? It is going up. Should I put it into the icy water and see if it goes down?
Yeah.
Does it look different than before?
It did go down. Was it moving faster or slower than before?
Slower?
It's moving more slowly, yeah. Oh, that one popped.
I don't think that bubble was quite as big as the last time when it was hotter.
I think when the water was more hot, and then right now it's just warm. That water is definitely cold, and this one's kind of warm. It's definitely warmer than the icy water. but it's not really hot. And I boiled the water earlier. Yeah, it looks a little lethargic. So on a day where the clouds, when it's not really hot outside, do you think the clouds are going to make a thunderstorm, or maybe just little clouds like my first one? Yeah.
Mhm.
Okay. Well,
All right.
I think we're all done. And thanks all for joining us. We're going to sign off, but if you look in the chat, you can find out some great links to NCAR, the National Center for Atmospheric Research, and we do lots of studying about hurricanes, tornadoes, air, hail, like Tim mentioned. So check that out, and there's a lot of cool things to look at there. Okay.
Bye.
Bye, everybody.
Great. Thank you so much. That
Thanks,
was
guys.
really great.
Is that Mark?
Yeah, that's
I'm gonna do something. Thank you.
You're welcome.
bye.
Bye.
Tell Tiffany I said hi.
I will.
Okay.
Bye.
I think our next presentation is starting in about 5 minutes. So you guys can just hang around for the next one.
Oh, these are
It'll
going to be some cool
start super
experiments.
soon.
Yeah, some cool experiments.